Upbeat, mysterious music starts and then fades to the background. Hey everyone, and welcome back to the channel. Today, we're diving deep literally into one of the most mind-blowing discoveries about our planet. Forget what you learned in geography class about the 7 seas. What if I told you that the largest ocean on Earth isn't on the surface at all, but is hidden hundreds of miles beneath our very feet? It sounds like something straight out of a Jules Verne novel, but I assure you, this is real science. So, grab your virtual submarine, because we're about to explore a vast, hidden world that could rewrite everything we know about our planet. So, where is this colossal body of water? It's not a liquid ocean like the Atlantic or Pacific that you could sail a boat on. Instead, it's a massive reservoir of water trapped within a special type of rock, located between 250 and 400 miles, that's 410 to 660 kilometers deep, within the Earth's mantle. To put that into perspective, if you took all the water from all the oceans on the surface and poured it into this underground reservoir, you'd only fill up about a third of it. This hidden ocean is estimated to hold at least 3 times more water than all of our surface oceans combined. It's an almost incomprehensibly huge amount of water. This discovery didn't happen overnight. It's the result of decades of research and a bit of clever geological detective work. Scientists couldn't just drill a hole that deep. The pressure and temperature are far too extreme. So, how did they find it? The breakthrough came from listening to the Earth itself. Specifically, by studying seismic waves, the powerful shock waves generated by earthquakes that travel through the planet. Imagine dropping a pebble into a pond. You see ripples spread out, right? Seismic waves are like those ripples, but they travel through solid rock. By placing thousands of seismometers all across the United States, a project called USRA allowed scientists to create a detailed map of the Earth's interior. They noticed something peculiar. As these waves traveled through the mantle at that specific depth of 250 to 400 miles, they would suddenly slow down. Now, in geology, when seismic waves slow down, it's a huge clue. It tells scientists they're passing through something different, something less rigid than the surrounding solid rock. After extensive analysis and modeling, they concluded that the only thing that could cause this slowdown on such a massive scale was the presence of water. Not liquid water, but water chemically bonded to the rock itself, making it wet and sponge-like on a molecular level. It's a bit like a saturated sponge, holding vast quantities of water within its structure. This wet rock is what slows down the seismic waves, revealing the existence of this gigantic underground reservoir. To truly understand this hidden ocean, we need to talk about where it's located: the Earth's mantle. The mantle is the thick layer of rock that sits between the Earth's crust, the part we live on, and its super-hot core. It's a dynamic, slowly churning layer that drives much of our planet's geology. Within the mantle, there's a specific area called the transition zone. This zone is a boundary layer separating the upper mantle from the lower mantle. And it's here, in this transition zone, that conditions are just right for this hidden ocean to exist. The secret lies in some really special minerals. The upper mantle is mostly made of a greenish mineral you might have heard of called olivine. But as you go deeper into the transition zone, the immense pressure and high temperatures cause olivine to transform. It changes its crystal structure and becomes different minerals. First, it squishes into a mineral called wodsleyite, and as the pressure increases even more, it transforms again into a mineral called ringwoodite. These names might sound complex, but here's the crucial part. Wodsleyite, and especially ringwoodite, have a unique crystal structure that acts like a molecular cage. They can trap and hold water molecules, or more accurately, the components of water, hydrogen and oxygen within their crystalline lattice. Ringwoodite in particular is a superstar water storer. It can hold up to 2.5% of its weight in water. While that might not sound like a lot when you consider that the transition zone is hundreds of miles thick and spans the entire globe, that 2.5% adds up to an astronomical amount of water 3 times the volume of our surface oceans. So, scientists found a sample of a rare diamond that had been pushed up from the transition zone by a volcanic eruption. Trapped inside this diamond was a microscopic speck of ringwoodite, and when they analyzed it, they found it contained water. This was the first direct physical evidence, confirming the theories based on seismic data. It was the smoking gun, proving that the transition zone is indeed a massive, water-rich sponge. So, what does having a 3 oceans worth of water locked away in the mantle actually mean for us up here on the surface? Well, it turns out it's incredibly important. This discovery is transforming our understanding of the Earth's water cycle. We usually think of the water cycle as evaporation from oceans, rain, and rivers flowing back to the sea. But this suggests a much grander, planet-wide water cycle that takes place over millions of years. Water from the surface can be carried down into the mantle through a process called subduction, where one tectonic plate slides beneath another. This water gets locked into minerals like ringwoodite. This stored water doesn't just sit there. It significantly affects what happens in the mantle. The presence of water can lower the melting point of rock. This means that as wet rock from the transition zone gets churned around by mantle convection, it's more likely to melt and form magma. This magma can then rise to the surface, leading to volcanic activity. Many volcanoes are essentially vents for this deep earth water to return to the surface. So, in a way, this hidden ocean is a key ingredient for volcanism and the creation of new crust. This deep water also lubricates the movement of tectonic plates. Plate tectonics, the process that drives earthquakes, builds mountains, and shapes our continents, relies on the slow, steady movement of the mantle. The water in the transition zone helps facilitate this movement, making the mantle less viscous and allowing the convection currents to flow more easily. Without this vast internal water supply, plate tectonics as we know it might not even be possible. Our planet could have been a very different, much less geologically active place. This discovery truly connects the deep Earth with the surface in a profound way. It suggests our planet has an internal plumbing system that has been regulating the amount of water on the surface for billions of years. It might even be the reason Earth has been able to maintain stable liquid oceans on its surface for so long, making it a habitable blue planet. If too much water were trapped deep inside, our oceans might shrink. If too much were released, we could become a water world with no continents. This hidden reservoir acts as a massive buffer, keeping things just right. This incredible finding opens up a whole new frontier for geology. It challenges us to rethink our planet as a single, interconnected system, from the deepest parts of the mantle to the clouds in the sky. The water we drink and the oceans we swim in might have once been locked 400 miles deep inside a crystal, on a journey that takes millions of years. It's a humbling reminder that even though we live on this planet, we are still just scratching the surface of its deepest secrets. There are still so many wonders hidden right beneath our feet, just waiting to be discovered. Thank you so much for joining me on this deep dive into the Earth's hidden ocean. What do you think about this discovery? Let me know your thoughts in the comments below. And if you enjoyed this journey into the unknown, don't forget to hit that like button, subscribe to the channel, and ring the notification bell so you don't miss our next adventure. Thanks for watching, and I'll see you in the next video.